Welcome back, Register audience. My name's Tim Phillips, and today we are talking about modernizing legacy applications using emulation. That's it. We are lifting and shifting today. We're going to be going through all the practical aspects of that. It's not something we talk about very much on the Register, and I think we should be doing more of it because it's very practical. It's something that I know a lot of you struggle with. And so today we'll be talking about why you should do it, how you do it, what the business benefits are and the costs, and talk about security and performance, all of that important practical stuff. Well, clearly I can't do that on my own. So who's going to be helping me today? Well, I'd like to introduce our two guests today. First of all, from Stromasys, John, welcome.
Hello, thank you for having me here.
Now, John, this is absolutely your business, isn't it? Can you tell me a little bit about Stromasys?
Sure. Yes, you're right. This is absolutely our business. This is all we do. And this is something we've been doing for 21 years now. So we were originally a management buyout from the old digital and initially providing services. And we've been doing emulators now for 16, 17 years. So legacy server emulation is our business. This is what we do.
And you'll have seen every problem along the way about this and also come across every solution about it. Yeah.
Indeed.
Good. Well, we test you on that. And also from AWS, because when you're shifting, you need somewhere to shift it to. Martin, welcome as well.
Hey, thanks a lot, Tim.
Now, is this sort of business something that you're seeing a lot of on your platform?
Yeah, we do. We've got, obviously, we've got lots of customers looking to move workloads to the cloud. And sort of looking at the 6 R's of rehosting and refactoring and re-architecting. But for some workloads, it just really doesn't make sense to sort of get inside them and try and unpack them. So this is definitely a great solution to have, and Stromasys is a great partner to enable moving these kinds of workloads.
Great. Well, what we are going to be looking at today, we'll be talking about why you do it, why you would need to do it as well, the costs, the benefits, as I said, and how you do it. So we'll be covering all of that in the next 45 minutes, a very practical session. So, but first of all, John, I really have to ask you, what do we mean when we're talking about these legacy applications? What's included?
So legacy system is a system, for us, it's a system that has been around for more than 10 years, 10, 15, sometimes 20 years, sometimes even more. And these are systems that usually run mission critical applications, and they encompass all the IP, all the know-how of the organizations or companies that run them. And they're still legacy for a reason. They're sticking around because usually, as we say, and you can see on the bottom of that chart there, each hardware has a lifetime of about 3, 4, at most 5 years. Then you need to think about refresh. The operating system has a longer one, maybe 10 years, but the application really can live on for 20, 30 years sometimes. And it's hard to decouple the application from the old hardware when the architecture changes. So legacy is something that is stuck, that there are not enough people around to know its insides. There is no source code. There is no one to maintain it. And it's really just hanging from a thread and stuck and living on.
But it's hanging from a thread, but these are fundamental to the working of the organization, aren't they? What sort of hardware are they on? What sort of things are they doing?
So they might be running a chemical mixing plant, or many of them. We have customers that are running hundreds of chemical plants around the world. They may be controlling the moving around of hot melted iron ore, steel, aluminum. They may be running air traffic control, or a nuclear power plant, or any kind of power plant, or a design of aircraft or satellites. I mean, how do you change a system that is directly controlled with a satellite up there? So it's these sort of things that are irreplaceable and very, very dangerous if you lose them.
Yes, but also causing sleepless nights to the people who are in charge of them. I mean, many of them will be watching this today and saying, absolutely, it's an ongoing worry for the organization, and we're going to find out why about this. This is the list of problems that you came up with, why this becomes a serious risk factor for the business.
Yeah, and really risk, as you said, that's the key word. But what people tend to focus on is today. What is it costing me today, and how can I reduce my operating cost today? I mean, we have a crisis out there, COVID. We have an economic crisis. We all need to cut costs, okay, and cut. But meanwhile, we have the problem that is getting bigger and bigger and bigger as time goes by. And this is what we wanted to discuss here today, that the more you ignore a problem, it's like a gun that is approaching with time closer and closer. And clearly there is the risk side and there's the operating cost side, and you got to address both. So yeah.
You were telling me about how spare parts tend to be sourced for this. Tell me again, it really is quite amazing.
So how would you feel knowing that a nuclear power plant is sourcing spare parts from eBay? And as a company, this is our biggest competition. It's people sourcing spare parts from eBay. And let me point out that spare parts that have been sitting on a shelf for 10 or 15 years, they're not new. You cannot put them in there and hope that, okay, I've solved my problem, I've got a brand new thing running in there. Not at all. They age, even if they're sitting around, and you don't know who had them before and what they might have done on them. So you're breaking all sorts of procedures there and all sorts of assumptions about your own security.
Clearly something that's not going on. Martin, this isn't really something that a lot of people would associate with AWS, which is considered really to be sort of looking to the future and everything, but it's extremely important, isn't it?
Sorry, for the rare customers that have these kinds of workloads, I think it's really important because lots of them, decide to make a move to cloud, but then, some of these workloads can sort of become an anchor that mean also that you can't realize a lot of the benefit that you're really trying to realize in terms of, being able to use data center hosting facilities for something else because you've still got this kit there. So, I mean, we see other reasons why people want to move to the cloud, which we'll talk about a bit later. But we definitely also see some of these workloads which, again, just can't be refactored to fit into the cloud natively.
Now, as you point out, John, the major problem is that we have a downtime risk, and that downtime is only going to increase in the future, isn't it?
Exactly, and downtime is already a problem. I mean, anybody who's running a mission-critical legacy system knows what that means to their weekends, because for some special law of nature, these problems tend to come up on weekends or late at night. But in general, 2/3 of companies today face unplanned downtime every week, an hour, 2 hours, and in general, 1/3 of those is because of legacy systems, unplanned downtime. And unplanned downtime, it's a technical term, but the audience here are engineers, they understand what that means. What does it mean to lose your payroll system a few hours before it's time to run payroll? What does it mean to lose a screen on an air traffic control? What happens to all the airplanes? Where do they go? What happens when you lose the balance and the load balancing of an electric power grid? There's things that you cannot repair afterwards. So downtime and the risk you're taking is really what this is about. Plus, of course, managing your current cost and reducing it and doing the best you can on that front as well.
So we get to a point here that something has to be done, but the sheer complexity of doing something when, as you say, there's no source code around, no one really wants to touch it, becomes the limiting factor. Now let's have a look at the options that you've put here, which is why we come down to lift and shift. Take me through this.
Sure. So I think, there we go. So, I mean, we got to analyze things on two axes. One is how risky are you, is the approach you're taking, and the other one is how costly. So the favorite one of most people is do nothing. Anybody who has adolescent kids knows what it's like. The exam is approaching, do nothing until it's the last moment. And as I said, this gun is getting nearer and nearer. That is expensive though, because you're looking for things that are more and more scarce and have people with skills that are more and more scarce. And it's extremely risky because sooner or later, that gun is going to get to your head. And then, so yeah, if you start looking for spare parts, that is more cost effective than doing nothing. You want to replace an old failing hard disk with a new one, but it's new only in the sense that it has not been used before, hopefully. But you still got it from eBay, you got it from somewhere that you don't know its history. So it is less expensive, but you haven't solved your risk problem. And then, of course, the longer term solution, we're not saying that, oh, you should move this to an emulated environment on AWS and you forget about it. What we're saying is you want to think about moving your application natively to Linux or Windows or whatever it is that you want to do. That takes time and it takes an enormous cost. And we all know it always takes at least twice the time and twice the cost that you were originally budgeting. So what you can do meanwhile, and meanwhile can be 10 years, we have customers running it for 20 years. You can lift and shift it very simply, put it on the AWS cloud running an emulator. The application looks at it and says, this is a VAX, this is a Spark, nothing has changed. And the next morning, because it's a backup and a restore, that's all it is. The next morning, the operator comes in, they boot up, they log into their user ID with their same password, the same screen, same functionality. Nothing has changed except it's a bit faster. And underneath, suddenly, the risk is gone. The gun is gone, it's come down. And the business and the CIO can sit down and think calmly and maturely all over their options. What shall we do now? How shall we deal with this in the next 20 years? Should we migrate? Okay, let's take our time. Let's run some tenders. Let's examine it. But the risk is gone.
Now, are you exaggerating here, John? So you're saying it's a backup and restore. You go home one night and you come back the next day and it's moved to the cloud. Is it really like that?
It is, with proper preparation. I mean, it doesn't mean that a customer will call us up and tomorrow you've got your system running on the AWS cloud. A lot of planning will go in it. We'll study it carefully. We'll prepare everything. And then that's all there is indeed, with a caveat that depends on how much data you have. That might take a few days to transfer, or a week, or whatever it takes. But yeah, I mean, we don't touch source code. We do not recompile. We do not ask customers to recompile. So there's no change. So all you have to do is just lift it, put it there, transfer the data, switch it on, and keep going.
And as you say, although some of your customers have been with you for 20 years and some have been with 10 years, surely the optimum is to use that to say, we can relax a little bit about this now. Now let's start thinking about optimizing our cloud deployment. Is that the idea?
That is the idea, though we, of course, would love to have our customers stay on for years and years. But yeah, that's what we're doing here. What we are here to tell customers that take your time, create options for yourself, get rid of the risk, face it, deal with it, and get rid of it for now. And then think calmly and decide what it is you want to do. We have customers, for example, the metro system of a very large metropolitan city, that they have commissioned a new system. It's going to take 10 years for it to be created, approved, because you got to go through new certifications, make sure it's connectivity and it's talking to all the other systems. So it takes a long time. So what do you do in this 10, 12 years? You got brand new hardware running out there, being taken care of by AWS, but you don't even have to manage it anymore. And it's all nice and smooth sailing.
Martin, do you see your customers going through this thought process?
Yeah, we absolutely do. I think we have customers that choose to go, cloud native using serverless technologies. In some cases, really in a position that they're able to commit and get the most out of cloud technologies. But we've also got lots of customers in sort of different stages of maturity and stages of adoption of cloud services. So, I guess another example of something similar is, the VMware on AWS solution that we've got, because some customers are choosing to run VMware workloads that span their on-premise data center and the AWS cloud. But I think the benefit of doing that is you do get to have a consistent experience, and you do get to move into a reliably operated environment, and you are now in the cloud. So I guess even for these really legacy applications, there must be bits of them that are not keeping up with regulation or not keeping up with business requirements. So the migration phase might not actually be about refactoring all of it, but really extracting the bits that are most likely to need change soon, and then being in a position of high agility to deal with those business change requirements.
Because we often, well, I have heard the whole lift and shift concept being presented as really for organizations that haven't got their act together or can't keep up or in some way deficient. The way you're talking about it, it's not really quite like that, is it? It's a strategic move, which is part of a process.
Absolutely. Yeah, absolutely.
Okay, well, let's have a look and see exactly what goes on during this lifting and shifting process. So, John, take us through this. This is how it all works.
Sure. Yeah. So what you have here on the bottom left, the red part is the problem, is the disease, if you like. It's a legacy hardware system that might be a Spark or a VAX or an Alpha or HP 9000 running HP UX. And this system has been running for a long time and it's failing, and you got to do something with it. On top, the green arrows is your application, your database, and your classic operating system. So your Solaris, your OpenVMS, your HP UX. These you want to maintain ideally. So what will happen is that we'll get rid of the hardware, and that will all be replaced by the AWS cloud either running Linux, or we can embed that in our own emulator so you don't have to manage it. Our emulator will be there. It's a pretty thin layer. And then on top of that, you move your application, your database, your classic operating system exactly the way it was. So that is the part that is lifted and shifted. The bottom, the red part, is the one that is replaced. The green part is the one that lifted, shifted, and deposited there, and it keeps working.
Do you have to do, are you required to do any modification, any coding at all?
Not at all. And that's actually the whole point. Our business is, our market is the customers who, for some reason, they either are not able or do not wish to touch the source code. There's no recompilation, because recompilation brings risks. And you can never know when you recompile, even if it's on the same environment, what will happen? Will it work? What if it doesn't? What are the usually there's very uneven consequence of that, the consequences are huge. You go down, system down. And that's why you just don't want to touch it. You take the environment the way you would take any backup, and you restore it in a different one as you would restore it on a new piece of hardware. And that's it.
What are the limitations of your platform when it comes to looking at these legacy systems? What can't you cope with?
Well, we're talking about legacy here. We define legacy as something that will be running up to 1.5 gigahertz of clock speed. And it would have a reasonable number of cores. So back 10 years ago, you wouldn't have a 4 gigahertz system, hardware running around. So sometimes people say, oh, exciting, you're in the Spark market. I want to replace my T7, which is running a T8, running at 4+ gigahertz. No. We are in the business of dealing with legacy, old stuff that is running up to 1.5 gigahertz, because there's an overhead in the translation. The translation is live, it's very efficient, and that's, if you like, that's our IP. That's to make it commercially interesting, it needs to be very fast, but still there's a significant overhead. So that would be the one. Other limitations are if there is some very quirky, very strange dependency on some card that controls something that we have not emulated yet. Usually we can deal with that. Most of these cases, we can actually emulate the card as well. And then we put that in our emulator, in our standard package, and life goes on. But
I
Yeah,
see. That's just kind of a little bit of extra work at the upfront, well, during the planning phase, to make sure that
yes,
everything's taken care of on
exactly.
that. Yeah,
Yeah.
yeah. And so I guess because you're not touching anything, it sort of doesn't matter that the original people who know what's going on in this aren't around anymore.
It helps if they are, but the skills that very much continue to be needed are the OS skills. So the Solaris, the VMS, the HPUX skills, these will continue to be needed. It's the hardware skills that are no longer needed. And usually these are outsourced, where we've never seen a customer who would maintain internal staff or maintaining the hardware with a screwdriver walking around fixing things. But the engineers that have all the Solaris wisdom or the HPUX wisdom, yeah, these are very much still needed. If they're not around, we will look for new ones for this, or we will provide the transition. But still, these are very useful skills to have.
And how long do you go without then shutting down the old data center, the old hardware, and moving it out for scrap?
You mean once it has been moved?
Yeah.
Well, it should be shut down immediately. We've seen customers with huge VAXs that take enormous rooms. I mean, each VAX is twice a refrigerator, and maybe they have 10 of those. And we say, okay, we're done. It's all in these 2 racks and it's finished. Shut them down. No. So we come back a week later, still running them? Yeah, because, well, eventually it's just a matter of building their own confidence. They shut them down. They still don't move them out. So they need a month to just get used to the idea. Then they move them out.
Yeah.
Because starting up,
yeah.
sorry to interrupt, but starting up a 20-year-old machine, that's not easy. Might take you 6, 7, 8 hours. People running around literally with screwdrivers and manuals and making sure that, it's working, it's not working. I've seen it done and it's not funny.
No.
Yeah.
No, but it's obviously been part of people's lives for so long and been dependent on it for so long, and it represents such a huge feeling of risk. Even if you actually objectively lowered that risk, then obviously there's an emotional component, isn't there?
And it's a habit.
Yes.
I mean, we humans have habits and they're hard to change.
Yes. Now let's look a little bit about the costs that we're dealing with here. Martin, tell me about how the cost equation works out.
Yes, I think this cost is really complicated. I think I'm not going to pretend that it's easy to understand. I think it's probably best to look for the biggest sources of cost and focus on sort of the top 5. But to get an overall view of all of your costs, it's kind of like this iceberg here. It's easy to see, what is the bill to my equipment provider when I do my 4-year refresh cycle, and sort of think, well, is that my cost, in an x86 world, not so much in the legacy world, like those providers aren't around. So it's, what's the cost of sourcing all of this equipment? But there is also the cost of, the energy consumption, the space. Like for lots of our customers, actually the space they want to use the space for something else. And there's a real value in getting that space back. But I guess in terms of just looking at the total cost of ownership, it's just appreciating that it's not the obvious stuff necessarily that is the total cost. Like we've often worked with customers and kind of come up against an equipment manufacturer. This is here's the quote they gave us, and when we run that in AWS, it's 50% more expensive. And it's like, well, yes, it would be, because that doesn't include the room, it doesn't include the power, it doesn't include the networking, it doesn't include the engineers walking the floor and replacing things that break. So like it's just really working hard to try and do an apples and apples comparison.
But your advice would be to anyone who's thinking about this, do think carefully about these things, even if that's factored in as a sort of a cost of doing business. It's not always separated out as a cost in itself, is it?
Yeah, and I think the risk that John identifies is, what is the cost for that what if, which nobody wishes for that to happen, but what is the cost of a 3 or 4 days of not being able to get the right parts? What would that actually cost you, and then sort of work that in as well.
Absolutely, John, because the cost of not doing anything is that inevitably, sooner or later, that will happen. And the best you're hoping for is it doesn't happen when you're on duty.
Yeah, exactly. Or if you're off duty, well, then you're called into duty. That's not very fun either.
Yes,
Yeah,
absolutely.
but yeah, that
Yeah.
is that's a certainty. And there is a cost on this chart that says unplanned downtime.
Mm-hmm.
It's a tiny little phrase with a very huge consequences, though.
Yes. Yes, exactly. We've been talking about it for forever on a lot of things. A bit of unplanned downtime doesn't matter incredibly. It's always irritating, but it doesn't matter
Yeah.
enormously. On the things that you're talking about, unplanned downtime matters very, very much indeed, doesn't it?
Yeah.
So now you've gone into a little bit more detail on these costs as
So,
well
yes,
for us. Yeah. So take us through this, because these are amazing numbers.
Speaking of costs, huh?
Yeah.
So here we have the annual maintenance costs, the power consumption, the heat dissipation, and this is a real life example. It was a customer running a VAX. They're still running it. It's a very large VAX, 3 units, and we took objective measurements of the reduction in annual maintenance costs. Well, it goes down 89%. Power. Well, power from something that is half a room to half a rack, how much can it consume? So it's 93.5% saving. It's really even more because, but it's up in the 90s. And then heat dissipation, you have this monster running and producing heat that needs to be cooled. And suddenly you only have, again, as I said, half a rack. So that goes down tremendously. And we had 93.6% reduction in this particular example. So yeah, on the one hand is what people don't want to talk about, which I think they should, and that is the risk. And on the other hand, you have the immediate savings. And if you go on the AWS cloud, it's not a CapEx anymore. It's an operating expense, and you will be having a lower operating expense for having resolved your risk as well. So it's a no-brainer.
And people sometimes object to lifting and shifting because they say it's not really optimizing your IT. But when you've got savings like this, I guess the idea is to then reinvest them in the next stage of whatever you want to do, even as you say, it might take 10 years to develop and a year to safety test.
Exactly. And unless you feel that your application really, you're happy with it, it does what you need it to do. In the case of a chemical mixing chemicals on a production plant, well, that you have new technologies there. You use AI, you use new tools that were not available back then. So yes, you need to change this application. But if it's a payroll system, it's a payroll system. Or if it's a system that manages an aircraft production, why don't you wait until the aircraft program finishes and you move on to the next one? What's the point of rewriting it?
One thing about this is that we don't have here, the cost savings will be staff cost savings as well. I guess people who do lift and shift successfully are running with a smaller IT department afterwards.
They would be running with much smaller IT departments, again, not on the operating system, the legacy OS. So the Solaris, the HPUX people, you still need those skills. But definitely you no longer need the hardware maintenance.
Now let's have a look at a little bit about more into why there is this move to the public cloud for these type of applications. Martin, what do you see from your customers about how people are making these decisions?
I think I won't go through all of these. I think some of them have been mentioned, but one is actually freeing up some of that cash flow and being able to switch from large capital expenses every N years to just use what we need when we need it and pay for it from that perspective. But also being able to, I guess, like for this kind of workload, which is not likely to, be turned on and off all the time. It's probably going to be running sort of for a sustained period. To still have the option to optimize commercially what that costs you by maybe buying in advance. The other of, I guess, just moving to AWS is getting that benefit from our economies of scale. And this comes across in think, many different areas, how we operate the regions. We've got our own silicon in our machines. We've started building our own processors. Like it's not that we're buying off the shelf components and trying to operate them efficiently. We're of the scale that we can actually sort of go far beyond that and build and use really, really optimized equipment for our own use case, and we pass a lot of those savings on to our customers in how we price. And then I think the cost savings is often sort of what's, I guess, what gets certain people interested, but it's really not the benefit that gets me excited about working with customers. For me, it's really is the agility and the ability for the IT organization to work much closer with the business and be that organization that can adjust faster to business demands and business change, and to do so in a way that the organization is comfortable with the risk that they're taking on, because it's not big changes to applications that carry massive amounts of risk, but many smaller changes, and implementing DevOps and doing all that kind of stuff in the cloud just becomes much more accessible to organizations. And then I guess it sort of leads on to the next slide a bit, but it's also about global access to infrastructure for some of our customers, in that even though many customers have a requirement, and especially for some of the use cases that John mentioned, I'm sure the customers would really have an opinion around which country that workload is running in. So it's important to understand the cloud isn't just sort of a blob of cloud capacity somewhere. These are really specific regions that our customers decide to put their data into. So if you're in the UK and you've got a workload that you want to stay in the UK, then you would run your workload in the London region. And how we build that infrastructure still gives you the high availability and a bunch of benefits that I think can be underestimated in terms of the lift and shift benefit, because it isn't quite optimizing or going cloud native, but you do get some of the benefit that the way we build the infrastructure is exposed to you.
It's a lot of people, a lot of reg readers I know have been very interested in how cloud interacts with regulation and also legal changes, things like the Cloud Act in the US. And I would guess, Martin, with these sort of applications, when we're lifting and shifting them, that is extremely important, because a lot of these applications will be in regulated industries.
Absolutely. And I'd love to, in a couple, talk about our approach to security. I think I just mentioned that with the number of customers that we have, we're really fortunate that we have lots of customers with a very high security bar. And all the customers that even have a lower security bar, potentially, they benefit from a highest common denominator approach, because we have to satisfy financial institutions, for example, that have really sensitive information and a really high bar when it comes to security. But it's important also to realize that adopting cloud doesn't outsource the obligation that you have to secure your customer data. So it'd be good to maybe talk about that as well.
Absolutely, yes. Before we do that, though, there's a thing you call here your availability zones. How do they work? What does that mean? What's an availability zone?
So if you hop onto the next slide, I think that's got a diagram with a breakdown.
That is it. There we are, an availability zone. Yes.
Okay, super. So basically, an availability zone is where we build a region. So if you imagine a region is, for example, the London region, it's not just the data center that we've called the London region. It's actually a collection of data centers, and we group these data centers into different availability zones. And the intention here is to enable our customers to deploy within a single region, so within a single data sovereignty requirement, and be able to run high availability across multiple availability zones. So what we do to maximize the availability for the region is we would source power from different providers if we can. We would have different network connectivity going into different availability zones. The availability zone is basically sort of the failure domain that you need to think about in terms of, I should plan that this might become unavailable, and I want my architecture to be resilient to potentially having a problem in one of these availability zones. And I think this is a benefit for these legacy workloads as well, which, for example, it doesn't shout at you in terms of a lift and shift, but when you lift and shift that onto a virtual machine within one of these availability zones, you can take really regular, really frequent backups of that machine and be able to stand it up very quickly in another availability zone. Should we have an event that impacts an availability zone? And I guess
think about you're going from running something inside a data center, a single one with really no DR, no viable DR planning, to having this. I mean, you're not just talking about being on the cloud. You're talking about availability zones and having such a robust DR here. I mean, totally different world.
And again, it does speak to the idea that lifting and shifting is not for the stuff that nobody cares about anymore. Yeah. We're doing it precisely because people really do care about it.
Yeah, exactly. So
let's also have a look at security and how that works. Security in the public cloud. This security is, we've covered this a couple of times on our Edgecast recently, in the public cloud, a shared responsibility. So Martin, who does what?
So the answer is it depends. But it is always a shared responsibility. It's never an outsourced responsibility. So I like to explain it to people that AWS is responsible for security of the cloud. So these are the services that we provide to you. If you're consuming a virtual machine service, then the underlying infrastructure, the rooms, the physical security, all of that stuff it's our job to secure that. And the customer's responsibility is for the security in the cloud. And that means, for example, really specifically, if you've got a Linux virtual machine that you've got from us and that has a public IP address attached to it, it's your responsibility to configure the firewall on that machine appropriately and ensure that machine gets patched appropriately, and to do all the things that you would do for a Linux machine on your premise anyway. The nuance is that it depends on what you're consuming. So for a Linux VM, you have to patch it, and you have to take care of the operating system. However, for managed database service, for example, like MySQL or RDS for MySQL, which just provides you with a managed MySQL instance, you don't have to patch the operating system, and you can't even access the operating system because you've outsourced that responsibility to AWS. And it's like security is absolutely, as we refer to it, as job zero. It's our most important function is to keep your data secure and safe. And we work with many customers. I work with public sector in particular. That's my focus customer set. And these are government departments, healthcare. Like these are industries with very, very high data security standards. And obviously we also understand customers can't just take our word for it. They're going to want to know. And sometimes we get asked, look, can we come and have a look for ourselves? And really that doesn't scale when you've got 1 million active customers. So our approach to that's on the next slide. So if you don't mind, is to get third-party auditors and organizations to come and look at how we're running our data centers. How are we implementing our security controls, and then generate compliance reports that we do share with our customers. Some of them are only under NDA, but you can get access to the details of how we run some of the underlying infrastructure through some of these reports.
John, is this something that tends to get people to worry a little bit, hold up the deployment of your solution, these worries about security?
Only, yes, there is, and that is perception. It's until they look into it and understand that their customers with equal or even more stringent security needs that already have resolved this. So I guess the two main reasons, I mean, you could ask if this is such a slam dunk, why isn't everybody doing it? And the reason is that, first of all, they don't believe it can be done. And second, it's something unfamiliar. So yeah, going to the public cloud, wow, these are my most important data. I'm a semiconductor company, and my design data is why I exist. How can I put that on the cloud? Well, you're not just putting it out there on the cloud. You're putting it in a very stringent, very security conscious environment that is managed by professionals who do just that. That's all they do. And so you're actually improving your security.
Yeah, this has been a conversation that's been going on. Well, it's certainly been going on in these sessions for 5 or 6 years now. Is the public cloud ready for that? And it takes a little while for perceptions to move on. The final thing that I want to talk to you about with regards to this is performance. Because as you say, then, you have the layer for the emulation layer, and people want to get at least equivalent performance. How does it stack up before and after?
Well, we would never advise a customer to get into a situation where performance is slower. Absolutely not. And we do hear sometimes that I just want to test the functionality. I'm not interested about performance. And we say, you know what, we don't even want to start this conversation, because nobody likes to see their system running slower. So in this case, I mean, a VAX was running at 400 megahertz, and now you're going into 3 gigahertz machines. And I think it's a very valid point, because some clouds will run old machines up to maybe servers running up to 2.2 gigahertz, or some people want to go on-prem and they take some recycled gear, which is quite slow, and that is not right for emulation. You need a modern cloud running state-of-the-art machines, fast ones that are running at 3 gigahertz or faster, and then you have no penalty. And that's, of course, something that is proven maybe in a POC, or I mean, it's something that is discussed in advance. We don't just go there and say, let's see how it is.
Mm-hmm. Do you end up using basically the same AWS services for most of your clients, or is it fairly highly tuned?
The majority, the concept of legacy moving to the cloud is maybe about a year old, that people really started embracing the cloud. And now we have dozens of projects going on. So it's still early to tell, but the majority are running, yes, on the same EC2 Amazon environment. On some cases, they go on more specialized ones, yeah.
Martin, when it comes down to it, you do offer such a wide variety of environments that is there anything that you would, it comes to you and you think, yeah, it'd be difficult to handle that?
I think, we continue to be challenged by our customers, and I'm personally amazed that we've got machines with literally terabytes of RAM that you can go get by the hour now. And I think the important thing is to understand that, we acknowledge that workloads are very different and that there is no one size fits all. And we take that approach in many things, database technologies, but also in, the real hardcore stuff, or the real hardware aspect as well, in terms of having different types of instances for different workloads. So, in this case, what John mentioned, I believe it's mostly the C5 family, which is, highly compute optimized instances, so that the emulation layer can perform as quickly as it's able to. But for other workloads, it might be that they need storage optimized instances, for example. So I think for us, it's really about offering the right choice, so that you don't necessarily just get a bigger machine, so you get a faster machine type thing. It's like, let's grow in the dimension where you really are constrained for your application, whether that's compute, memory, storage, or networking capacity.
And so to round us off, I mean, when we've gone through all of this, and the question that came up when we were talking about this before is, with all of this going on, why is there still legacy? Why are there still why is there still business for you, John?
There is business for us, thankfully, because of human nature, because everybody wants to deal with the immediate problem facing them today, the visible problem. If we go back in the iceberg, you want to deal with the visible stuff, not with the invisible one. And it's the failure of the business side, really, I think, to understand the risk that they're taking. this is not just about IT. This is about risk management. It's not just about finance and costs. It's about risk management. It's about business continuity. It's about being able to run your business day in and day out reliably and be there for your customers. So, and then of course it's also the perception, as I mentioned earlier, that it cannot be done, or that going on the cloud, oh my God, how am I going to put my data on the cloud? Well, these are all issues that can and are being addressed.
Okay, so considering, as we come to the time to wrap up, considering that they can and are being addressed, I'd like from each of you, we've got these links here, and I'd like from each of you something that someone in our audience is thinking, all right, we will look at this again. What should they be doing now, straight away, this week? John?
They should go right on our website or give us a call, and we'll discuss with them based on their estate and look at the workloads. Should we be doing a POC maybe or not? How straightforward is it? And what is borderline and what is not? What is a yes and what is a maybe? And maybe what is a no as well?
Mm-hmm. Do you ever come up? Do you have many no's?
I'm sorry?
Do you have many no's? Do you have many inquiries that you think?
No, only not within the legacy environment. There are no no's. Within the architectures that we emulate, of course. Mm-hmm. There are other architectures that we have not touched yet that they do have demand, yeah. And we'll be moving there sooner or later.
Okay. Martin, you finish us off. What should what should people be doing about their legacy environments?
Yeah, I think I would propose, dive deep, as we say within Amazon, is really, and with that, I mean, get to the details, get to the specifics. I think you can make lots of assumptions that would make you not want to take action around security or compliance or performance or all kinds of things that or excuses that we sometimes see customers making. And we're very, very, very happy to be challenged on those and get with you and understand what your risks or your concern or your challenges, and just share what we have seen in that. And also share perspectives from other customers who've really spent a lot of time and effort to get to the bottom of these, and then ended up making the decision, in most cases, to move to the cloud. So I guess that would be my call to action is, don't just fall for all of the FUD and the challenges and stuff out there, but dive deep and get to the bottom of it and make up your own mind.
Well, we know from the Reg readers, and we also know from what's going on around the world, that there are plenty of businesses re-examining their IT models, re-examining the whole business models at the moment. So from what you're saying, then maybe some of this is going to be wrapped up in it. So if you have been watching this today and you're thinking about giving that a go, good luck to you. Let us know how it gets on. But first of all, we have to say goodbye. John and Martin, goodbye, and thank you very much.
Thank you very much.
Thank you.
And thank you for everyone who tuned in for this. As I say, I hope you found it useful. Let us know if you did, and let us know if you want us to cover this again, because it's an interesting subject and it's definitely one that's going to blow up over the next couple of years. But meanwhile, from me, Tim Phillips, and all of us at the Register for this time, goodbye.